In this video, we're going to look at and discuss and even solve exponential equations. But before we can do that, we really must look at all the various properties of exponents, which we will use as tools in order to solve the exponential equations. So the very first property, number one. So first we're going to let m, n, a, and b be real numbers. And a has to be greater than 0 and b has to be greater than 0. So we must define these before we start using all these variables in our properties. So number one, the very first property is if you have a to the m times a to the n, this will result in a to the m plus n power. Number two, if you have a to the m to the nth, we call this power of a power, then you will have a to the m times n. So you take the product of the powers. Number three, if you have a times b to the m, then this will result in a to the m times b to the m. So in other words, you are going to, like before, multiply the exponents. It happens to be that the exponents of a is 1 and b is 1, and so m times 1 and b times 1 will be just m. Okay. Number four, 1 to the m is equal to 1. So 1 to any exponent is equal to 1. Number 5. Number 5, a to the 0 is equal to 1. So any variable or numerical value to the 0 power will always be equal to 1. Number 6, and this is probably one of the most important and somewhat the most challenging for most students to get, and that is a to the negative exponent is really equal to 1 over a to the m. Okay, so this is really 1 over a to the m. You can think of this as it's the reciprocal of that one specific term, and when you do that, you then change it to positive. Number 7, a to the m over b to the n is equal to a to the m minus n. So you are subtracting the exponents. Number 8, a over b to the m. This one really corresponds with number 3. It's a very similar property. This will result in a to the m over b to the m. So in other words, similar to number 3, you have a to the 1 and b to the first power, and what you essentially do is multiply those exponents. Again, multiplying the exponents, not the base. We now are going to use those properties with one additional relationship to help solve these equations. And this is the relationship. It's an if-then statement. So if a to the u is equal to a to the v, then we know something. Since this is an equation and both sides are equal and the bases happen to be equal, the bases happen to be a in this case, what do we know about the exponents? And I hope that you said in your head that they have to be equal. So u has to be equal to v. So we are going to use this relationship along with the properties to solve the following 5 problems. So the first problem, we have 2 to the negative x is equal to 16. Well, the first thing we'd like to do so we can use the relationship stated above here is to get 2 and 16 to have the same base. Well, there's not much I can do with the left side. I can't really change 2 to the negative x into any other base, but we can change 16. Remember, 16 is really 2 to the 4th. All right, 2 times 2 times 2 times 2. And so now that we have the bases the same, we can then use the relationship above and say, well, if the bases are same, then we know that the exponents must also be the same, so negative x must be equal to 4. Now to solve this, we'll divide by -1, and so x is equal to negative 4. So you can go ahead and substitute this back in and say 2 to the negative of negative 4 is equal to 16. Well, the negative of negative 4 happens to be positive 4, and 2 to the 16th happens to be 16, so 16 equals 16, and it does in fact check out. All right, let's go to the second problem, and again we're going to do the same exact thing, except with the second problem you notice how, again, the left side looks pretty much, there's not much I can really do with that, but the right side there is, and this goes into the one property of exponents that tells us we can rewrite this as 5 to the negative 1, because it's 5 would be the reciprocal of 1/5, but if we're going to change it to the reciprocal, we must then include the negative exponent, and it'd be negative 1. Now, in order for us to solve this, again, now we have the bases the same, so we can set the exponents equal to each other and solve. So we subtract 3. So x is equal to negative 4. And again, we could go ahead and substitute this in to check, which is something I highly recommend everyone do on all these problems since they are solving equations. You can verify that your answer is correct. So 5 to the negative 4 plus 3 is equal to 1/5. That would be 5 to the negative 1 is equal to 1/5. And so that would produce 1/5 is equal to 1/5. So it does in fact check out. Okay. So I look at these problems, I look at number 3, and I say to myself, number 3, the left side does not appear as though I can do anything to that left side. However, the right side, I see the 125, and I feel like there's something I can do with that. So what I'm going to ask myself is, can I rewrite it with a base 5? So I put a little blank right there, and I said 5 to what power is 125? So that's what I'm asking myself. 5 to what power is 125? And it happens to be 3. So 5 to the third is 125. So I'm basically substituting 5 to the third in place of my 125. Now I'm going to use another property of exponents, which tells us that I can multiply these two exponents here. So now I have 5 to the x squared plus 8. That's all an exponent, by the way, is equal to 5 to the 6x. Well, now I have the same basis, so I can now set the exponents equal to each other. So x squared plus 8 is equal to 6x. And I can solve this quadratic. So I'll have x squared minus 6x plus 8 is equal to 0. Remember, with a quadratic, we have to set it equal to 0. So we get this quadratic, and we know that quadratics can either be solved by factoring or solved by completing squares or even the quadratic formula. I choose to factor, and the factors happen to be x minus 4 and x minus 2, which results in x equals 4 and x equals positive 2. With number 4, I've introduced this new variable called e, and e is similar to pi. It's an irrational number. It's 2.17 approximately. It's non-repeating, non-terminating, and we can discuss what e means, but it's essentially similar to pi. We will treat it as a variable, however, when we are doing this problem. So we have e, and we notice we have 4 and x, and we can go ahead and multiply those to be 4 times x times e to the x squared power is equal to e to the 12th. So remember that when we have bases the same and we are multiplying, we can add the exponents. So this will be e to the 4x plus x squared is equal to e to the 12th. So now I have bases the same. I have only one base on the left side, one base on the right side, so I can set the exponents equal to each other. So I have 4x plus x squared is equal to 12. Again, I have a quadratic, so I can then have x squared plus 4x. I'm rewriting these so that they're in standard form. Minus 12, moving the 12 over to the left side, is equal to 0. So again, I choose to factor this to solve. So I have x, and I have 6 and 2, positive and negative. So this produces x equals negative 6 and positive 2 for my solutions. Now with this fifth problem, again, I have e as my basis. So on the right side, what I'd like to do is convert this or use the properties of e exponents to change this so we only have one base e. So that's my goal right now. So we have e to the x squared. Not much I can do with that, nor do I want to. And we have e to the 3x, and there's not much I can do with that at this point. However, what I have here on the right side, the very last part of this term, is 1 over e squared. And I want that to be base e, so that way I can use other properties to combine these. So I'm going to use the one property that says I'm going to take the reciprocal of 1 over e squared. And in taking the reciprocal, it changes the exponent to negative 2. So now I have two bases. They're in the numerator. So then I can use the other property of exponents, which says that I can combine these to the same exponent by adding, because I am multiplying the bases. So 3x minus 2, because 3x plus a negative 2 is 3x minus 2. Now we have the same basis, so I can rewrite this with just the exponents, setting them equal to each other, 3x minus 2. Now I like, this is another quadratic, and I like to solve it when my leading coefficient is positive. So I'm going to move everything over to the left side. So x squared minus 3x plus 2 is equal to 0. I'm then going to go ahead and factor this. So I have x minus 2 and x minus 1 is equal to 0. And finally, I solve the two binomials, so I have x is equal to positive 2 and also positive 1. And again, I know I didn't do it with the last couple problems, but I strongly encourage you to check these two answers.
And knowing the half of the battle, yeah, yo, Joe!